For the function f of x equals negative x squared plus 4x minus 3, find the intervals where the function is increasing or decreasing. All right, so what you need to do is you need to find your critical points. You do that by taking the derivative, setting it equal to 0, and solving for x. Critical points gives you a local maximum or a minimum, right? If you have the derivative, if the derivative is positive, your function is increasing. If the derivative is negative, it's decreasing. So what we need to do is find the critical points and make a sign graph based off of that information. So the derivative of f of x is going to be using the power rule. So the derivative of negative x squared is negative 2x. The derivative of 4x is plus 4. The derivative of negative 3 is nothing. Set it equal to 0, and solve for x, right? Subtract 4, negative 4 equals negative 2x, divide by negative 2, divide by negative 2, and x equals positive 2. So whatever this graph looks like, I know it changes its direction from negative to positive or positive to negative, whatever, at 2. So this is my f prime, okay? This is my derivative sign graph. What I need to do is I need to pick values and plug it into the derivative to see if I get a positive or a negative slope. So I'll pick easy numbers like 0 and 10 and plug them in and see what happens. So f prime of 0 is going to be negative 2 times 0 plus 4. 0 plus 4 is 4, which is a positive number. Now let's do the same thing with 10. Negative 2 times 10 plus 4 is going to equal negative 20 plus 4, which is negative 16, a negative number. So based off of this information, since the slope is positive all the way up until 2, we can say that my function is increasing on the interval negative infinity to positive 2. Since my derivative is negative from 2 on out, we could say that my function is decreasing on the interval 2 to positive infinity. And we kind of know that because that's a parabola that's going downward. So, if we kind of just do the whole vertex form thing, found out that x is going to equal 2 here, this all makes perfect sense. But you know what? We used calculus instead, and that's just so much better. Function f of x equals x cubed minus 3x squared plus 4. Find the intervals where the function is increasing or decreasing. All right, so what you have to do first here is find the critical points. The critical points exist where your derivative is equal to 0. So let's take the derivative and set it equal to 0. The derivative of x cubed is 3x squared. The derivative of negative 3x is negative 6x, and 4 just disappears. What I can do is factor out a 3x, and that leaves me with x minus 2. So using the zero product property, my critical points are at 0 and at 2. Hooray! Now what I'm going to do is I'm going to make a sign table for my f prime function. I have zeros at 0 and 2, and I need to type in or find out numbers that are in these intervals that I can plug into my derivative, which was this guy, and find out if I have a positive or negative number. So I'll pick negative 100, 1, and regular 100. Okay, so I'm actually going to plug into this formula because this formula will kind of help me figure out the derivative better. So I'm just going to rewrite f prime of x can be written as 3x times x minus 2, and this will actually be a little bit more convenient for me. You'll see why. Okay, so let's do all three of these numbers. F prime of negative 100 is going to equal 3 times negative 100 and negative 100 minus 2. Positive times a negative is going to equal a positive. So I don't care about my number. I just care about what I get. And so this interval right here is going to be positive. f prime of 1 is going to be 3 times 1 times 1 minus 2. Positive times a negative is going to be negative. So you're going to be negative. Let's plug in 100. F prime of 100 is going to be 3 times 100 times 100 minus 2. A positive times a positive times a positive is a positive. So it looks like I'm increasing from everything all the way up until 0. So increasing from negative infinity to 0, decreasing between 0 and 2, of course not including any of these, and also increasing at 2 and on. So 2 to infinity. And A is going to give me that. So there you have it. Given the function f of x equals sine x plus 0.5, find the intervals where the function is increasing or decreasing on the interval 0 to pi. All right, well, what I have to do is I have to take the derivative and set it equal to 0 to get myself some critical points. So the derivative of f prime of x is going to be cosine x plus nothing. So set that equal to 0. Now, if I were to inverse cosine both sides, I would take the inverse cosine of 0 and the inverse cosine of cos x, making these guys cancel out, and then I'm left with just x's. Now, cosine is 0 at 2 spots in between 0 and 2 pi. It's 0 at pi over 2 and 3 pi over 2. So I'm going to make myself a sign chart based off of that information right there. Okay, actually a cosine chart. So here's my, what did I call it? F prime of x. I'm stopping at 0. Okay, stopping at 0, but I'm allowed to include 0. So that's nice. I have pi over 2. I have 3 pi over 2, and so I'm going to choose these numbers to plug into my derivative, of course, being cos x, to see what type of value I get. So I'm going to plug in 0 because I'm allowed. I'm going to plug in 2 pi because I'm allowed, and it's going to give me the same exact thing. And I'm going to plug in regular pi because it's nice snugly in between. So f prime of 0 is cosine of 0, which is positive 1. So you're positive. F prime of pi is cos of pi, which is negative 1, negative. F prime of 0 is the same thing as f prime of 2 pi, so you're positive. So it looks like we are increasing on 2 intervals in between 0 and 2. So we're increasing between 0 and pi over 2. And we're also increasing at 3 pi over 2 and 2 pi. That would mean we're decreasing between pi over 2 and 3 pi over 2. So that gives us A. All right, fun stuff. Find the intervals where the function is increasing or decreasing. Now, the way you find out if something is increasing or decreasing is you take first the derivative and set it equal to 0 to find your critical points. Also, we care about where this guy is going to be undefined. So we're going to have a sign graph that involves probably 3 pieces of information, if not more. So let's take the derivative of this guy. And if you're thinking, is that quotient rule? Yes, it is. So u prime is going to be the derivative of the top, so 2x, not so bad. V prime is going to be the derivative of the bottom, which is 1, not so bad. And then v squared is going to equal x plus 1 squared. Quotient rule is u prime v minus v prime u all over v squared. So f prime of x is going to equal u prime v, so 2x times x plus 1, minus v prime u, which is going to be 1 times x squared minus 1, all over x plus 1 squared. Set it equal to 0. You're going to distribute that, so 2x squared plus 2x. You're going to distribute that, so minus x squared plus 1, all over x plus 1 squared. Let's multiply both sides by x plus 1 squared to make it go away, because we really don't need it. All right, boom. So 0 on the left, you're gone. We have 2x squared minus regular x squared is going to equal x squared plus 2x plus 1. That's going to be, oh, that's it. I was going to put all over something, but we're not going to put it all over something. That is a perfect square trinomial. So 0 is going to equal x plus 1 squared. So this is interesting. We have multiplicity going on here. Ooh, and not only that, but okay, let's take care of that thing first. Multiplicity, let's take care of that thing first. Multiplicity usually means something weird is going to happen. Okay, so 0, my number that's going to make that 0 is going to be -1. Coincidentally, the number that makes this is also, the number that makes it undefined is also -1. Huh. So I'm going to have a sign table where -1 is the only guy that I care about. So f prime, I could choose numbers like 0 and 100 and plug them into f prime. So if I plug them into f prime, okay, and I plug in 0, what did I get? That was f prime at its cleanest form. Let me just rewrite out f prime. F prime in its cleanest form was it was x squared because it was these guys plus 2x plus 1 over x plus 1 squared. So plugging in 0 would give me 1 over 1 squared, which is 1. So you're positive. Plugging in a huge number like 100 would be 100 squared, so a positive plus a big positive plus a positive all over a positive squared, which is a positive. So plugging in 100 also gives me a positive. Remember when I said that multiplicity is going to give us something weird? Well, this guy is never decreasing. So what we would say is it's increasing. Let me use a different color and write it over here where I have the space. It's going to be increasing at everything up until -1. So negative infinity to -1, and also -1 to positive infinity. And it's going to be decreasing never. Huh. What a strange problem. And this actually kind of does make sense. And let's just break it down why it will make sense. Just a quick picture. Okay? You got slant asymptote stuff going on here because this guy is greater than that guy. And the way you find the equation of a slant asymptote is you do polynomial long division. Polynomial long division is you basically saying, well, let's divide x plus 1, x minus 1 divided by x plus 1 That'll cross out, and so your slant asymptote is going to be y equals x minus 1. X minus 1. So you're going to have a picture with the slant asymptote that looks like this, right? And you're going to have something that looks like that and something that looks like that, which means at no point will it ever be decreasing. So you got a little bonus stuff there, but yeah, that's how you do that problem. Kind of weird, kind of fun.